Over the summer, I made this Nix course, and I wasn't gonna post it. It's not really my style, but I was rewatching it, and it's not bad. So I think I'm just gonna post and see what happens. Let me know if you like it. Otherwise, I'll probably delete it. So thanks for watching. Hopefully this is edifying. Leave a comment below if I helped you out. Hello, and welcome to Adopting Nix at Your Startup. I'm Cam. I have a little sunburn, and in this course, we won't be rehashing the Nix documentation, but instead giving an overview of Nix and showing the fastest way to get started using it as a team. Well, why should you listen to me? I've been coding for over 20 years, 10 professionally at startups, big companies, and even some of my own. I've seen engineering orgs succeed and fail, and I'm here to share it all with you. So why should you care about Nix? Nix is a powerful package management system emphasizing immutability and pure functional deployment. With its declarative configuration, you can guarantee that package dependencies are precisely what you define every time. For startups, this translates into fewer works on my machine issues, streamlined development processes, and robust reproducible builds. Nix's ability to manage dependencies across multiple languages can also significantly simplify your CI/CD pipeline. Whether you're new to Nix or have some prior experience, this course is meant to deepen your understanding and help you leverage Nix in your startup. In the coming videos, we'll explore Nix's installation, configuration, and integration into different development workflows. We'll dive into advanced features, real-world applications, and best practices. This is a hands-on course, so be ready to engage with the code, practical examples, and underlying principles that make Nix a valuable tool for your startup. We'll see you in the next video. Welcome back to Adopting Nix at Your Startup. Today, we'll examine the core principles of Nix, including immutability, reproducibility, and Nix's architecture, with a focus on how these principles are implemented. Immutability in Nix ensures that once a package is installed, it remains unchanged. This is implemented through the Nix store, where each package is assigned a unique path derived from its hash and dependencies. For instance, a change in a package's source code or dependencies results in a new path. This eliminates conflicts, ensures consistency, and allows for easy rollbacks since previous versions remain unchanged in the store. Reproducibility in Nix ensures identical environments across different machines. It's implemented via declarative Nix expressions where everything about a package, including dependencies and build instructions, is explicitly defined. The use of Nix build, the CLI command, reads a Nix expression and builds it in isolation. Any change to the environment won't affect the build, ensuring it's the same every single time. This ensures the eradication of the infamous "it works on my machine" problem. The heart of Nix lies with its unique architecture. Nix takes over a directory at /nix/store with read-only files. In the Nix store, packages are kept in paths containing a cryptographic hash of their dependencies and build instructions. Nix expressions define how to build packages using the Nix language. They're evaluated using the Nix instantiate command, which produces a derivation. Derivations are the build actions that Nix takes to construct a package, and they are themselves stored in the Nix store as well. Garbage collection is another essential feature, clearing unused packages from the store. Thanks to the hashing mechanism, Nix can accurately determine what's no longer needed. You can invoke this with Nix collect garbage. So we just dove into the underlying mechanisms that make Nix a powerful tool for consistent and isolated development environments. These details form the basis for our continued exploration here. In the next video, we'll tackle installation and the initial configuration of Nix on your machine, so be ready to run some code. We'll see you soon. Hey, welcome to the third installment of Adopting Nix at Your Startup. Building on our understanding of Nix's core principles, today we're going to get hands-on with the installation and configuration of Nix. Let's pop over to the terminal. Installing Nix is a pretty streamlined process. On most Linux-based computers, you're going to run one command. I have it below, but if you don't trust that. You can just go to the Nix documentation and copy paste it. You're basically downloading a script and running it. So make sure you know what you're doing before you run this. Read the documentation. But I'm going to run right here. This is going to install Nix in multi-user mode, which means that the Nix store will be owned and managed by a daemon rather than the user directly. So on Linux, you need to add -- daemon for multi-user or -- no daemon for single user. I'm on OS 10, so I just copy paste. Let's give it some permissions here. Make sure you read all this because you're creating users, you're creating read-only directories. It's going to do a lot of stuff, but if you say yes, it's going to confirm everything that you're going to do here. So make sure you take your time here and be careful. And I have installed this before, so I have some leftover files. We're going to remove these and try again. So again, it's telling us what it's going to do. We're going to confirm that. So we're done installing. This last message is kind of important. It's basically saying you need to start a new tab in your terminal to have the Nix CLI commands in your path. But otherwise, we have this command here to test that everything works. So open a new tab, try this out. This is creating a new Nix shell with the package Nix info, and we're going to spit out information about the installation. So everything worked. Let's move on to configuring Nix. So now that we have Nix installed, let's talk about the nix.conf file, where various settings can be adjusted to fit your environment. This includes binary cache settings, build options, and more. Definitely check out the documentation. It's extensive. But you shouldn't have to worry about it locally too much, but you should know where it is. So let's open it up. It's at etc nix nixconf. We're going to actually have to use sudo because this is a read-only file managed by Nix. And you can see here there's not too much in here. There are a couple things that we could play around with. One is enabling experimental features like flakes. So we can add experimental features equals flakes. And next time you run a Nix command, flakes will be enabled. If this were our CI, we could also set up binary caches. We'll talk about CIs in a future video, but here's an example of setting up binary caches locally. This configuration enables both the official Nix cache and a community cache, making package installation more efficient. So there you have it. It's super simple to install Nix and get it configured quickly. In the next video, we're going to define your first project with Nix, so stick around, check it out. Hey, welcome back to Adopting Nix at Your Startup. Now that we have Nix installed and configured, let's actually start using it to define a project. The first Nix command you should learn about is Nix shell, which can create temporary development environments. Here's how to enter a shell with a specific package. So we run Nix shell -p for package, Node.js. It's going to download everything we need from cache.nixOS, and it's going to drop us into a shell with the package that we requested. In this case, we can run node-v, get the version, and we can see that we just dropped into a shell with node 18.16. And if we exit and run node-version again, we have a different version of Node installed. So that's one package, but we may have many packages necessary for a project. We can use Nix expressions to formalize shell requirements for a project, turning it from a temporary shell into a permanent one. So let's say we have a Node.js project we're working on. We can create a shell.nix file for it. Within this shell.nix file, we want to call the make shell function. This is going to take the packages that we define and put them into a shell for us. So we're going to add the Node.js package here. We could even add something like htop if we wanted it. and we'll save that. And now we'll run nix-shell with no arguments. It's going to detect the shell.nix file, evaluate it, build it, and now we're dropped straight into that Nix shell. So I could run htop, or I could run node-v, and we can see that we have that node version installed as we did earlier. Okay, so we've got this definition that we can now check into our version control. We can share with our team. Now the entire team has the dependencies that our project needs. We still have to now run Nix shell every time we want to drop into this and activate the dependencies. So I want to show you one more tool called direnv, and it solves this problem. So it's at direnv.net. Check it out. You're going to have to install it. I already have it installed, but basically the idea here is that it ties into your shell and it can run commands automatically when you enter a directory. In this case, it actually has a built-in command called use Nix that'll automatically load up this Nix shell for us. So here's how we're going to do it. We'll drop back into the shell here. We'll get out of that Nix shell. We're going to create a .mvrc file. I've already set this up previously, but all we have to type out here is use Nix. We'll save this, and now we'll see an error here. The directory is blocked, so it's not just going to automatically run any .mvrc file. You have to run direnv allow, and now we've added this to the allow list for direnv. It's gone out and built that Nix shell, and now if we drop out of this directory and go back to it, we can see that when we enter the directory, direnv loads up. You'll notice that we're not within the previous Nix shell prompt. We're within our own prompt. So this ties into our shell. If I run node-v, we actually get the version of node that we've installed here. We have htop as well. So we just tackled the basics of how to use Nix. And next we're going to talk about some ways to integrate it into your CI pipeline and some other cool tricks. So stick around and we'll see you in the next video. Hey, welcome back to Adopting Nix at Your Startup. Today we're going to talk about Nix in your continuous integration pipeline. So we have Nix installed. We used it to define our project, and now we want to use it to run tests every time we have a pull request. So for this video, we're going to assume that you have GitHub Actions. There's other CI tools out there like Jenkins, but we're just going to cover one today. The ideas here are going to be the same, primarily the fact that we're not going to use shell.nix. We're going to use a new file called default.nix. So let's open that up. And you'll notice that we're using make derivation instead of make shell. So what this is going to do is create a DRV file and also a build artifact with Nix build. So there's a couple things going on here. We've named our project. We've defined the source of the project. So that's critical because Nix will hash all of the source files, and anytime you change this, it's going to create a new output artifact. We have our build inputs and install phase. This is where you would run npm install or compile the front end of your project, something like that. So we can run this by just running nix-build, and we can see it doesn't do much right here, but it does output this my project file. So there's nothing in it right now. But if we were to go back into this, we could echo hello to the out file. We'll rebuild this. We can see that the hash changed because the output has changed. This is really important for your build pipeline because if something changes, you want to change the artifact. If we cat that out, we can see that hello has been added to this build artifact. So this isn't very important. Let's change that back. So looking at this project, we actually have a JavaScript at the bottom called tests. We can take a look at that really quick. We have a failing test here. So if we run node test.js, it'll output an error. We also have a package.json file, so we can run npm test. Additionally, we have this .github directory. Inside, we have this YAML file, which defines our test workflow. So inside here, we check out the repository. We'll run this Kashix install Nix action. So it's literally just going to install Nix. Then we'll run Nix build like we just did locally. And then we run npm run test inside the Nix shell. So if we open up GitHub, now we can see anytime we push to the main branch, the action is going to run. Inside GitHub, you can go to actions and click on a test run. We wanted this to fail, and we just got the same assertion error that we received locally. So that's great. That means that if we're pushing back code, the CI is going to catch that. So let's go back to the terminal and fix our test. Let's say 1 is equal to 1. And fix the test. Push it up. And we're going to wait a second for GitHub to run the test. The cool thing about GitHub Actions is that you can actually follow along as the CI runs your tests. So it looks like we passed our tests. And now the CI is green. So why would you want to do this? With GitHub Actions specifically, you could just npm install really easily. The critical thing to remember here is that Nix is language agnostic, so you can use this no matter what tool you have, and it integrates into your dev workflow. Remember that. I also want to show you one more tool called Kashix. The idea here is that when you run Nix build, you can cache that output between test runs. So this can save you a lot of time when you build stuff. Let's say you just change your tests and you don't change any of your project code. You can just re-download that cache and you're ready to go. That can save you minutes or hours over the course of a week. One more thing I want to talk about is version pinning. So Nixpkgs is a reference to a channel. And if you're in a shared environment, you want to pin that down and make sure that your entire team is using the same channel version. You can do that really easily here by running the import function. And in this case, we're describing a tag from GitHub. And we can now rerun Nix build. And it's going to pull down that zip file. It's pretty big, so it's going to take a little bit. It's going to use that in place of any channel for Nixpkgs it was using before. So since we're using a different channel, it's actually starting from scratch here. You can see it's downloading a lot of packages compared to what it did before. But now the entire team is using the same Nixpkgs definition, and the builds are going to be even more reproducible. Thanks for following along with Nix for continuous integration. Hopefully you have GitHub Actions set up now and configured with your project. In the next video, we're going to talk a little bit more about Nixpkgs, but also take a look at NixOS. So stay tuned and we'll see you in the next video. Hey, welcome back to Adopting Nix at Your Startup. And today we're going to talk about Nixpkgs and NixOS. So we alluded to Nixpkgs in the previous video or two, and it's pretty self-explanatory. It's the Nixpkgs collection. But what does that actually mean? So in reality, this is a big Git repo. It's very active. So you can see there's 4,000 pull requests open right now, and it changes all the time. So when you're dealing with shell.nix file or even in NixOS, what we're talking about is the Nixpkgs unstable channel here. So that's what this is. And then every once in a while, they'll cut a stable channel, and that's really the safe option to use. Or if you want to live in the Wild West, you can use this Nixpkgs unstable channel. But this actually allows you to contribute your project to Nixpkgs. So how do we find Nixpkgs? We could go back to this repo and we can click through. There's this organizational structure. We can look at games. But there's a lot of stuff here. So the first thing that we want to talk about is search.nixOS. This is kept up to date with the stable channel. You can also search the unstable channel, and let's type in Linux. So we have the Linux kernel. and it has build instructions in a Nix expression for the Linux kernel here. So from here, you can find pretty much every piece of software that you're looking for, but you may not always be in a browser, right? So let's go back to the terminal here, and we can run Nix search Nixpkgs Linux, and it's going to go out, grab that channel, and then search through it locally. Tangerine LaCroix, so good. So we've just searched through the entire Nixpkgs channel for the term Linux. So this is obviously a pretty popular keyword, but we could also search for something like DaVinci Resolve, and with this we can find the package that we're looking for. So that's Nixpkgs. It's kind of like the heart of Nix, honestly, and being able to search it is really useful. So let's talk about NixOS. NixOS takes the principles of Nix and applies them to the entire operating system. We won't cover everything. We won't cover much here, honestly. I'll make another course on it. There's so much. Every aspect of the system, from the kernel to applications, is defined declaratively in a single config file. You can spread it out, but it all starts from etc nixos configuration.nix. So instead of simply defining your project in a Nix file, you can define an entire system that it runs on as well. So different Nix packages will actually allow you to configure them, and this allows you to do stuff like run a web server with pure Nix configuration, like 1 or 2 lines. You can build complex systems by composing different Nix modules, anything from user management to different network setups, right? And this is all way more than a theoretical concept. I'm running NixOS on a personal machine, and many different organizations leverage Nix packages and NixOS for a robust system config, package management, and even continuous integration. So you can imagine it's really useful to define your project with Nix, and then it's even more useful to define the entire system that it's running on for the CI and for your production environment. Target, Replit, and Spotify are pretty notable users. By defining builds declaratively, you can create a reproducible and efficient CI/CD pipeline, enhancing reliability and performance. Today, we've talked about the capabilities of Nix packages and NixOS. We're really just uncovering the tip of the iceberg here, so definitely check out the documentation. But the flexibility and extensibility and coherence of these tools really make them vital in a startup environment. In our next video, we'll tackle some more advanced topics, so stay tuned and we'll see you there. Hey, welcome back to Adopting Nix at Your Startup. Today, we're going to talk about some more advanced Nix topics, Flakes and NixOps. So Nix Flakes introduce a new way of managing Nix projects. They provide reproducibility and discoverability. So here's what you need to know. Flakes are self-contained Nix projects with clear inputs and outputs. It's a file, flake.nix, with a consistent schema. Flakes provide a consistent interface for dependencies so that they can link together. So your flake can use another flake as an input. So if we want to create a flake, the first thing that we need to do is enable them. Flakes are technically an experimental feature of Nix. That just means that the RFC hasn't been approved fully and it's still subject to change, but it's going to stick around, it seems like. So it's not enabled out of the box. We covered how to change your config in the installing and configuring Nix video, so we're going to move forward assuming that you've already enabled flakes. So the first command that you're going to be interested in is nix flake init. This is going to create a flake.nix file. It's really basic. We can see that it starts out with outputs, and we have this packages object. So out of the box, it's going to define only packages for x86, 64 Linux, and we have a hello package and a default package which points to it. So this doesn't do us much good, especially because I'm on a Mac and this isn't going to do anything. So let's look at a slightly more interesting flake example. So here we have inputs and outputs, and we are also calling this function each default system. So we're not just defining variables for x86, 64 Linux. We're going to loop through and define something for each system. In this case, we're going to define a dev shell. This is really similar to a shell.nix file. And we're going to download Node.js and call node-version every time we enter this directory. Another thing that's interesting here is that direnv also has a tool to deal with flakes. So I added an envrc file. Instead of use Nix, it just says use flake. And so what that'll do is if we type in direnv allow, it's going to build this flake, and we can see here that shell hook has been run. If we go to a different directory, I can run node-version. We actually have a different version of node. So we can see that as soon as we enter this directory, it's going to build that flake and initialize the shell environment. Now, if you want to build the flake directly without direnv, you can run nix build. We're going to get an error here because we never provided a default package for the current system. So let's open the flake back up, and we can add packages.default. And we have this pkgs.hello that's going to evaluate to Nix packages, legacy packages, AR64darwin.hello. And so we'll save this and we'll rerun nix build. And now we can see we have something in the result directory. So we can run result bin hello. Let's also talk about the Nix Flake registry. So on your computer, there's several different registries. They're a bunch of JSON files that link to Nix Flakes. And so we used two Nix Flakes in the previous example, Nix packages and Flake utils. Those are in the Nix Flake registry. We can look at it by running Nix registry list. We can see all of these global flakes. There's also system level flakes, there's user level flakes, and then project level flakes. So you can also add to this list by running Nix registry add. Check out the help for this if you're interested in learning more. One interesting thing about this is that it's not namespace to Nix Flake registry. It's just Nix registry, but it just deals with flakes. So I think something interesting happening with Nix right now, all of the CLI commands are moving to be flakes centric, even though flakes are an experimental feature. So it's one thing to think about. Flakes are going to be a much bigger deal than they are today, and you should probably be looking into incorporating them into your project. We should also really talk about NixOps. So the idea here is you take the power of Nix and you extend it to deploying entire systems. So the way it works is that you write a Nix expression describing the entire system, including machines, network configuration, and services. It's kind of like NixOS, but you're doing it over the network, and you have a CLI to deploy and manage servers. Let's take a really quick look. Again, this is maybe the tip of the iceberg. I'm not going to cover everything here. I might even make a whole course on this. We're just going to look at how to deploy something really quickly. So I have this file here, server.nix. So we can see here we are starting an HTTP service with Valgrind docs, and we're going to deploy to a VirtualBox target env. You're going to run nix shell-p NixOps, and I have to run the unstable version. The stable version just won't compile for me. You're also going to need VirtualBox installed. It doesn't work on M2 Max, so I can't do that at the moment. So we're going to go as far as we can here. I'm going to run NixOps create-d and name your deployment. We'll call it server. We can list out all of our deployments by running NixOps list. It's going to take a second. Now we can copy a UUID here. We can say NixOps info-d UUID. Now we can see that we've created a deployment with a machine and a VirtualBox type. Now if I had VirtualBox, we could run NixOps deploy-d UUID, and it'll go out, launch a VM, and install all of the services that we'd find. So that's it for our advanced usage of Nix. With Nix Flakes, you can create modular, reproducible projects, while NixOps empowers you to deploy entire systems effortlessly. Join us in the next video for more insights into the world of Nix. Thank you for tuning in, and we'll see you in the next video. Hey, welcome back to Adopting Nix at Your Startup. In this video, we'll explore troubleshooting, optimization, and how to engage with the Nix community. Let's dive in. So Nix is powerful, but like any system, it can have its quirks. Let's examine some common problems and solutions. So the first thing that happens a lot are build failures. These are usually caused by missing or incompatible dependencies. There's a couple really easy solutions. It sounds really stupid, but first we want to check the Nix expression for missing semicolons. This happens all the time, and the errors are just kind of opaque. The next thing that you can do is run Nix log, and you can inspect the build logs. The last tip here is to use Nix show derivation, and it'll allow you to analyze builds. Another thing that can happen pretty frequently is disk space issues. So Nix stores all packages, including old versions, in the Nix store. The solution to this is to utilize Nix's garbage collection, and we're going to talk about this more in a little bit. The last thing that can come up are permission errors. So running Nix commands without the right permissions can definitely cause issues. The solution to this is to install Nix in multi-user mode. If you want to install Nix in single user mode, you're kind of on your own, but you can also check the Nix manual for more guidance on permissions. Optimizing Nix can make your builds faster and more efficient. Here's how. There's 4 different ways we're going to talk about. First, you want to leverage binary caches. Binary caches store pre-compiled packages, reducing build times. You can host your binary cache or utilize a cache service like CacheX. You want to parallelize your builds. You can enable parallel builds in your nix.conf by setting max jobs to a suitable number, like the number of cores on your machine. You can even set up a build farm. Nix has this tool called Hydra. You can set up a distributed build farm using Hydra to parallelize and accelerate builds. Substitutors are another great way to optimize Nix. You can configure trusted substitutors to pull pre-built binaries from trusted sources. To do this, you edit the substitutors option in your nix.conf. Nix's garbage collection is crucial for managing disk space. You can run garbage collection manually by running nix-collect-garbage to remove unused packages. You can automate this by scheduling a cron job or a systemd timer to run garbage collection regularly. And then you can also optimize the existing store by running nix-store-optimize, and it'll deduplicate and reduce storage usage. The Nix community is a pretty valuable resource. Places like the NixOS discourse and IRC channels are great for looking for help or sharing knowledge. I'll link them down below. Your contributions to the Nixpkgs repository can help the community. Make sure to follow the guidelines provided in the Nixpkgs manual, and your contributions might actually end up helping somebody out. There may even be local user groups or NixOS meetups to engage with other people in your area. So there's always more to learn about Nix. The official documentation is a really comprehensive source. There's something called Nix Pills, which is a deeper dive into Nix for those wanting to explore a little bit further. And then, of course, there's the NixOS wiki, which is going to come up on Google for most of your searches. It's a collaborative space for shared knowledge. This wraps up our exploration of troubleshooting, optimization, and the Nix community. These insights, coupled with the principles we've covered throughout this course, equip you with the expertise to adopt Nix at your startup effectively. In the next and final video, we'll provide a concise recap of everything that we've covered, along with insights on how to continue your Nix journey. We'll see you in the next video. Welcome to the conclusion of our course on adopting Nix at your startup. We've come a long way together, exploring a multitude of facets around Nix, NixOS, and how they can revolutionize the way that startups approach development, deployment, and more. So let's reflect on what we learned. We started by understanding the importance of Nix for startups, focusing on efficiency, consistency, and scalability. We then dove into the core concepts of Nix, including its immutable nature and how it guarantees reproducibility. Then we dropped into the terminal and talked about the foundational steps of setting up Nix and configuring it with some hands-on experience. We explored how to define projects using shell.nix, creating a cohesive environment for the entire development team. We talked about enhancing your development workflow with tools like Durenv and CI integration, streamlining collaboration and deployment. We talked about Nixpkgs and NixOS, opening doors to a myriad of packages and a powerful OS tailored for Nix users. We ventured into the advanced role of Nix Flakes and NixOps, unleashing more flexibility and power from the platform. And then we capped our journey with rapid fire tips, insights, resources, and best practices to keep you thriving with Nix. So if you're a software engineer at a startup, what you've learned here isn't just knowledge, it's an invitation to innovate. With Nix, you've unlocked a toolbox that's tailored to meet the evolving needs of modern startups. From seamless deployment to robust security, from rapid development to streamlined deployment, Nix offers what startups need most: agility, reliability, and efficiency. Your journey with Nix doesn't have to end here. The community is vibrant, the resources are plentiful, and the possibilities are endless. Keep exploring, keep innovating, and remember, Nix isn't just a tool, it's a different way to think about interacting with our software environments. Thank you for being part of this course. I hope to leave you inspired and equipped to leverage the power of Nix at your startup. Go out there and make a difference. Thanks for watching.